Question 9 here is taken from the Leaving Certificate 2022, the spring paper, and we've got a triangle where we've got field 1 and field 2, and in the first part of the question they want us to find the area of field 1. So area of field 1. So the way we do this is the triangle for field 1 here, so we're going to use the formula half AB sine C basically. So therefore we got like half times, this is going to be our value for A, 30 meters, and that's our value for B. Okay, this could be A and B or A and B here, it doesn't really matter. So half AB, so half 30 times 35 times the sine of the angle between these two sides, 50 degrees. So there's the sine of 50. Let's take a calculator here. So 0.5, which is half, times 30 times 35, we get this much, and let's see if our calculator is in the degrees mode. So there we go, times the sine of 50. We come up with 402.1733 and so on. So area is 402.173326. So we can say that this is approximately 402 meters squared to 3 significant figures. Now that's the first part done, so easily done. The second part, they want us to find the area of field 2. So area of field 2. So how are we going to do this now? We don't have enough information to just use this triangle only, because this side here is missing, this side is missing. We can find that, but let's try and find an easy way of doing this. Maybe we could find the area of the whole triangle. So area of the whole triangle, the whole field, field 1 and field 2. And so that's going to be again half AB sine C. This time our A is going to be 40 times B, which is 35, times the sine again of 50 degrees. So that's going to become 20 times 35 times sine of 50. And again, we can use our calculator here. So 20 times 35 times sine of 50. We'll come up with a value of 536.231102. So 536.231102. So now it's kind of easy for us to find the area of field 2, because we take the whole triangle, subtract this field 1 here, and you're going to get just field 2. All right, so field 2, area of field 2 is going to be equal to the whole area of 536 minus 402. So let's do that. Minus 402. We're looking for three significant figures. That comes to 134 meters square. So that's the second part of the question. This is part A of the question, but A is comprised here of two parts. So we're going to look at part B of the question. And part B, they want us to find the perimeter, the length of the perimeter of field 1. Okay, so just let us write this down. Perimeter length of field 1. So how are we going to do this? The perimeter is basically the sum of all the sides. Okay, so we're going to take field 1 is A, C, and then you got this part here, which is from the question see B, right? So this is B. So A, B, C. We got 30, we got 35, but we just need that one. So how are we going to find BC? We can use the cosine rule to find BC. So basically now, if we want to find BC, let me just draw the field down here, so I don't have to move my copybook around too much. All right, so there we got 30, I got 50 here, and I got 35 here. So what I want is, to be able to find the perimeter, I need this side here. So this is BC. Like I said, what we can do, we can use cosine rule. So if we use cosine rule, basically I'm going to state the cosine rule. I'm going to state it. So BC to the square. So that's basically BC to the square is equal to then AB square plus AC square minus 2 times AB times AC, okay, times the cos of the angle between the two sides, cos BAC. So that's going to be BC square is equal to then 30 to the square plus 35 square minus 2 times 30 times 35 times the cos of 50 degrees. So the way I do this, I put this in my calculator first. That's going to be then 30 square plus 35 square, and that's going to be 2,125. So I get it right in this way, in this manner. I don't just put all the information in the calculator. It might generate the wrong answer. Okay, so 2 times, and this one is separate, 30 times 35 times the cos of 50. We come up with 1349.85398. So now here 2125 minus what we just got, and we come up with BC square is equal to 775.146097, and you can take the square root of that if you remove the square here. So that's going to give you 27.841444. And so on. So what we're saying is that BC is approximately 27.8 meters. So therefore the perimeter is going to be just the sum of the three sides that we know now, 30, 35 and this. So then if we add these up, we're going to get, so this plus 35 plus 30, so that comes to 92.81, I mean 92.84144 and so on. So 92.84144, etc. And therefore to the nearest meter, is that so? Because let me just take a look at the question. Yeah, they're saying to the nearest, even the first part, nearest meter square. So to the nearest meter, that's going to be 92 meters then. So 92 meters to the nearest meter. And here we are. I'm just going to call the perimeter P. Right, so this is my second part. Okay, in this part of the question, this is part C of the question, we are told that Oscar is also watching an airplane, P, flying directly over his head. Now this is where Oscar is standing. He's watching the plane flying from here to there. And as he does so, he's standing at the point O in the diagrams, okay? So the x-axis is the horizontal ground, and the y-axis is it runs vertically upward from Oscar. All right, so here is Oscar. So that's he's watching the plane, and the airplane is flying at a constant height of 10 kilometers, which means that it's neither flying further up beyond 10 kilometers or below. It's just flying straight here, and this distance, the height of the plane is constant, is 10 kilometers. Now, if this is 45 degrees, then you would also agree with me that here, because the horizontal and vertical makes 90 degrees, so this should be then 45 degrees. So if this is 10, so this is going to be 10, and if you use Pythagoras theorem, we got 10 to the square plus 10 to the square, which is basically 10 square plus 10 square is equal to OP to the square. So basically we got 200, all right, and then so that's going to be OP is then square root of 200. So the square root of 200 is 10 root 2. So that's going to be 10 root 2 kilometers. And what we're saying 10 root 2 kilometers is this part here, that distance here. There's further information that the speed of sound is approximately, roughly 343 meters per second. So speed of sound, I'll just put this here, speed of sound is roughly 343 meters per second in air. Now, as the plane flies, its engine makes noise. Okay, of course, the plane's flying, the engine's making noise. Basically, we understand that the noise is traveling at that speed. So we need to use information. It takes some time for this sound to reach Oscar. So it takes some time for the noise from here to reach Oscar's ears here. And we need to use the information in diagram 1 to show that it takes approximately 41 seconds for the sound of the plane, the airplane makes at P1 to reach Oscar correct to the nearest second. So we need to show that it takes the time taken is equal to approximately 41 seconds for the sound, okay, to reach Oscar. So if we want to find time, basically we're looking at distance divided by speed. So the distance we know is 10 root 2. So we know the distance. So the time is going to be equal to the distance divided by the speed. And here we're talking about the speed of sound. So the distance is 10 root 2 kilometers. And because this is given in meters per second, so we need to convert the 10 root 2 into meters. So multiply by 1,000 because a kilometer is about 1,000 meters. And so you divide by 343. Let's see if we get an answer here. So this is this much, and then you divide this by 343. And here we go, 41.23 seconds. So that's been shown then, is approximately 41.2307161. Therefore it's approximately 41 seconds, and that's been shown. Here we are, we proved it. Okay, in part C again, but this is the second part C of the question, we are told that the airplane is flying at a constant speed of 255 meters per second. Now that's the speed of the airplane, 255 meters per second. Let me just write this down. Okay, this is going to be our second part. Airplane has a speed and is flying at 255 meters per second. That's quite fast. And by the time Oscar hears the sound, the airplane made at the point P1. Okay, by the time when Oscar is standing here, he can hear the sound that is made from the plane at P1. Okay, the airplane has flown onto the point P2. So here we are in the second diagram, in diagram 2. So by the time the sound travels all the way from here down to here, the plane has flown from here to here. So I'm sure you see the logic. And now work out the size of the angle theta in diagram 2. So based on that information, we need to find this small angle here, which is theta. All right, and this angle, we need that correct to 1 decimal place. So now to be able to do this, first of all, I want to find out what is the distance that the plane has traveled from P1 to P2. So if we were to find this distance here, we know the speed of the airplane is 255 meters per second. And we know the time it takes to travel from here to here is 41 seconds. That was the first part of the question. So in the first part of the question, right, so then we calculated that the exact time taken was 41.23 seconds, but we're going to be taking the 41 seconds here. Okay, so that's the time taken. So the time is 41 seconds. So remember, we're trying to find the distance, and we know that distance is equal to speed multiplied by time. And what is the speed of the airplane? It is 255 meters per second. All right, and so that's going to be then 0.255 kilometers, all right, per second, times the time taken is 41. So if we do this on the calculator, we're going to get 10.455 kilometers. So that's 10.455 kilometers. So basically, that's the whole distance. That is P1 to P2. Let me just write this down. P1 to P2. So if this whole distance here is 10.455, we did observe that if this was 10 and this is 45, this would be 10. So what we have is that from here to here, you've got 10 kilometers, basically. So now, but from here to here, that small distance here, this is going to be equal to 10.44, I mean 10.455. So 10.455, take away the 10 kilometers, you get 0.455 kilometers. So basically we're saying that this is 455 meters. Now that's the distance we have here, 455 meters. So to make this easy, I might have to draw the triangle again here. Let me just do that quickly. So basically we have a triangle like this now. So again we can use trigonometry. This becomes quite easy because we got a 90 degrees there. So we can use the SOHCAHTOA. So this is 90 degrees. We want to find theta. We know that this is 10 kilometers. And this one is 0.455. So if I want to find theta, this is my opposite side, and that's my adjacent. Of course, this is the hypotenuse. So opposite adjacent, we can use SOHCAHTOA. So one of them is opposite adjacent is tan. So we say tan of theta is equal to the opposite over the adjacent, which is then 10. So I'm going to say divided by 10, and I get something like 0.0445. So this is going to be 0.0455 rather. So the theta is going to be equal to tan inverse or arctan of 0.0455. So let's do this. Sorry about that. Just bring this over here. There we go, so you can see clearly. All right, and so tan inverse of it's going to be make it 2.605. So 2.605 degrees. So to one decimal place, you're going to get theta as 2.6 degrees. So in part D of the question, we have a new diagram here, and where P3 and P4 are two other points on the flight path of the airplane P. By the time Oscar hears the sound the airplane made at P3, the airplane has flown on to the point P4. So by the time the sound travels from P3 to Oscar here, the plane has already traveled from P3 to P4. So that should be the same as this, right, in terms of time. All right, so therefore, as shown in the diagram here, and it's not drawn to scale, P3 and P4 are both at a distance of d kilometers from the y-axis. So d kilometers here, d kilometers here. Now we need to explain briefly why the following equation holds. That is square root of 100 plus d squared over this and 2d over this. Now if we look at d and d here, this is the distance of the airplane. So the distance, okay, divided by the speed, and the speed of the airplane was 0.255 kilometers per second. All right, and which is this is the time, and then the time it takes from the sound to travel from P3 to O is going to be some distance here, which is 100 plus d squared, the square root of that, divided by this. So this is how we can explain it. So the way I'm going to explain this is very easy. So what we're going to do is we're going to look at the time the sound takes to reach Oscar, and we just did say that it was the distance divided by the speed of sound, which is this square root of 100 plus d squared, which is the distance the sound travels, divided by the speed of the sound, which is 0.343. And that basically is equal to the distance from P3 to P4, because remember, when he's standing here, by the time he hears the sound, the plane has already traveled from P3 to P4. So this is equal to that. So basically the distance from P3 to O divided by the speed of sound is the time that it takes for the sound to reach Oscar from P3, and it's the same time that it takes for the plane to fly from P3 to P4. So the time the plane takes to go from P3 to P4, distance of the speed again. So here we're talking about the distance of the plane, which is d plus d is 2d, divided by the speed of the plane, which is 0.255, and the distance of the plane divided by the speed of the plane. Now both of these times are equal, since it takes the sound. Let me just write this again. It takes the the sound to reach Oscar. Okay, since both of these times are equal, since the time it takes, since the time it takes the sound to reach Oscar is equal to the time it takes the plane to travel from P3 to P4. So this is done. So the last part of the question, we need to solve this equation to find the value of d to correct to 1 decimal place. So what I'm going to do is, I'm just going to cross multiply. So I can say that the square root of 100 plus d square is equal to 2d times this. So that's going to become then 2 times 0.343. So that makes it 0.686 over 0.255. So if I were to remove the square root, so I divide this by 0.255 and I get this much, 2.69 something. Alright, so that's going to become then, let me see. Alright, so there's a d here. Alright, so basically I'm saying that I've got 100 plus d square. If I were to remove the square root, I'm going to get 0.686 d, all of that, 0 over 0.255 to the square. So let's see, where do we go from here? So 100 plus d square is equal to, this is then 2.69916078 d square. And so this can come this side, and you get then 1.690196078 d square, because this d can come there, so minus 1 d square, and then all of that's going to be equal to 100. So 100 divided by this, so get 100 divided by 1.690196078, 100. So I think I messed up a little bit here, so let's just do this in our calculator again. So here I'm going to take 0.686 divided by 0.255. This is my result, and I square it and I get 7.237. So this is going to be then 7.23715,494. So the d square can be subtracted there. This is d square. So if we do that, this can be taken there. You're going to be left with 6.23715 and so on, d square. All right, and you've got 100 on this side. So what we are going to do then is that we're going to say d square is equal to 100 divided by 6.23715 and so on. So 100 divided by what we just found is 16.03. So this is going to come as 16.03295107. So d is equal to the square root of all of that. So if you take the square root of this, we're going to get 4.004. So d is equal to 4.004, etc. So I can see that d to 1 decimal place, d is going to be equal to 4.0 kilometers. This is to 1 decimal place. Here we are, done for this question. Take care.